Welcome back to our Kentucky Small Ruminant Masterclass. Today, we're going to be taking up the topic of hay storage. Hay storage can be defined as managing the weather damage that our hay receives between baling and feeding. One of the things that we need to be aware of, especially with round bales, is that their geometry greatly affects the way that we lose dry matter. And by that I mean the outer 6 inches of a round bale is about 33% of that total volume. So if we lose that outer 6 inches, we lose 1/3 of that round bale of hay. This drawing is done, and actually they've calculated this cutout here, this shaded area, and that's about 20% of the volume. And as we will see, moisture absorption from the bottom is quite damaging to hay. I'd like to refer you to UK publication AGR 62, which goes into a lot of depth about weathering losses in round bales. The work was done by Dr. Mike Collins here at the University of Kentucky. One of their studies compared 4 different storage methods and the dry matter losses and the depth of weathering. Let's take a look at the 4 systems they were comparing. The black bar is net wrap directly stored on the ground. The next bar is solid plastic wrap with open ends stored on the ground. The next is twine tied bales stored again on the ground. And the last bar, the white bar, is inside stored hay. 2 points I want to make from this graph, and that is that net wrap is better than twine alone for outside stored hay directly on the ground. And in this study, that was the net wrap lost 23% of the dry matter during outside storage versus 34% for the twine tied. And that solid plastic wrap, now this is a type of wrap we don't see very often anymore, but it had solid plastic wrap around the round dimension of the bale, and then the ends were open so that they could breathe and moisture could escape. But solid plastic wrap was almost as good as inside stored hay. This is some research done by Dr. Kevin Shinners at the University of Wisconsin, where he looked at water absorption in round bales stored on pallets or on the ground. These were all net wrapped hay after 5 months and after 11 months. The bluer the zone, the wetter that zone was. So you can see that after 5 months, net wrapped hay stored on a pallet had absorbed some water from rainfall along the side, but very little then from the bottom or the top. Even net wrapped bales stored on the ground had only a small region of this very wet hay, and with moisture content though beginning to seep in all along about 2/3 of the circumference of that bale. After 11 months though, these bales had absorbed quite a bit of water, and the net wrapped on the ground was probably mostly lost due to all this moisture content in the bale. So we do get greater moisture absorption from the bottom of our hay when we store it outside on the ground. This is a summary of a lot of research done here at the University of Kentucky, where they compared the storage system life and the approximate cost for a 1,000-pound bale and dry matter loss for several different storage types, from a conventional shed all the way down to just a round bale, twine tied, stacked on the ground. And what you can see is, while the systems may have varying lifespans and varying cost per bale per year, you can see that several of these systems actually are almost equivalent in terms of dry matter loss, ranging from the conventional shed or a pole structure with a plastic roof on a pad, reusable tarp on a pad, a bale sleeve on the ground, and plastic wrap on the ground. Then as we begin to go into look at other systems, our losses then go up. But you can see that you have several systems where we have basically equivalent losses. So you have many options when you start to think about what kind of hay storage am I going to use. I want to touch just briefly or talk just briefly about this new development in wrap for round bales of hay. It's called breathable net wrap or B-wrap. I'm showing you the John Deere literature because that's what I could find in terms of who marketed this option. But B-wrap is marketed to shed water. In other words, the rain will not penetrate the bale, but it lets moisture out of the bale. In other words, the bale can go through the sweat and lose the moisture that it's going to lose after you bale it. And in fact, research does confirm that B-wrapped hay is comparable to hay that is stored inside. The catch, the estimated cost is $5 over the cost of net wrap. So we do get the benefits here, so we get good benefits, but the cost of doing this is actually going to be about equivalent probably to putting up some sort of a structure. However, this may be an option when structures are not an option. Another thing that affects dry matter loss is the moisture content at baling. And here is the point right here at the bottom, that dry matter losses in storage are approximately equal to the baling percent moisture minus the equilibrium moisture, which is about 15% in Kentucky. So if our baling moisture is in the 15 to 20% range, then our dry matter loss would be negligible, 1 to 5, just due to the moisture alone. If we're above 20% moisture, then our dry matter loss is going to be 5% or more, again, equivalent to that baling moisture minus the equilibrium moisture in Kentucky, which is about 15%. Another point I'd like to make about hay stored outside is that the better the hay is, the more it suffers when it's stored outside. This is some work done by Vic Lechtenberg up at Purdue University that compared the quality of weathered and unweathered portions of grass and grass alfalfa hay in round bales. So we had two types of hay, and then they stored it outside, and then they measured the digestibility, crude protein, and ADF, acid detergent fiber, of the unweathered portion and the weathered portion. Interestingly enough, the digestibility of the grass and this grass alfalfa mix were about the same initially. The grass, though, declined from 58, or almost 59, to 43, or 42.5. The grass legume from 56.5 to 34.2. And at a digestibility of 34.2, this is almost not usable by livestock, at least this weathered layer. And it bears up what we often see is that when we have a bale with a highly weathered layer, that livestock will oftentimes just pull it off and move it to the side and not consume it. Another fact is that weathering hurts those smaller bales more. Again, going back to the round bale geometry. If we lose 4 inches due to spoilage, if the bale is 3 feet in diameter, that's 40% of the volume of the hay. If it's 6 feet in diameter, it's only 20% of the volume of hay. Another question that we get a lot is, what about old hay? And we've had the opportunity in the past several years to test hay that's been in a barn and kept dry for several years for its energy value and its protein value. And what we find is that hay will retain protein and energy values for long periods, even years, as long as it is kept dry and clean. I'd like to go into one example of something that we see quite commonly in Kentucky now, and that's these hoop barns for storing hay. I'm going to talk a little bit about the important things you need to do if you're going to create one of these or use one of these, and also the economics. Ventilation is crucial, and you can see these built a lot of ways, but we recommend that air can come in from the bottom and can move around the stack and then move horizontally towards either end of the bale structure. We also recommend that we break contact with the ground, that there's some sort of a bottom barrier, gravel over plastic or gravel over limestone, so that we do not get direct movement of water into the bottom parts of these bales. This actually is a real example, and these are real figures, at least as of 2017. This is a 30 by 72 foot barn on gravel, and this is a turnkey figure, about $9,500 in 2017. So I'm sure more expensive now. But for 2,160 square feet, that means we were able to, or this producer was able to build this barn for about $4.40 per square foot. So if you look at the width and the bale dimensions and how many bales we can put in this barn, then our capacity is about 210 of those 1,200 pound 5x5 bales, or 126 tons. And I'll use these figures to calculate some of the payback numbers in the following slides. In order to calculate whether we can afford to build this barn or not, we have to know how much loss we experience storing outside with our current system. I highlighted our 5x5 bale here. Of course, our table has losses from 2 up to 8 inches, but I highlighted the 6-inch loss figure, which I'll use for the next slides or two. So if you look at a 6-inch loss with a hay value of $60 a ton, which is reasonable, then that is, we would annually have lost, or in other words, we would save, if we built the barn, 2,722 pounds of dry matter over leaving the hay stored outside on the ground. If you look at the years to pay back that $9,500 with 5x5 bales, again, same value, same loss, that comes up to be about 3 years, simple payback. And of course, the greater the depth of loss and the more expensive the hay, the shorter the period of payback. So to summarize, hay storage, it really is managing weather damage or moisture between baling and feeding. Breaking the ground contact is the first priority for outside stored hay. Most moisture is absorbed from the ground. Many storage methods will keep losses low, but inside storage is best. Thank you very much.